Large language models, or LLMs, they're everywhere these days. They're in our chatbots, our creative tools, and wow, they feel incredibly intelligent. But here's the thing, there's a huge catch. Behind all that brain power is a fundamental problem, a kind of digital amnesia that keeps them totally stuck in the past. So you've probably run into this, right? It seems like such a simple question. You ask your go-to AI assistant about the big game last night or a news story that broke this morning, maybe even what the stock market is doing. And what do you get? Crickets. Usually just a polite apology about how its knowledge is limited. So what is actually going on there? Okay, so here's the breakdown. It's really all about this fundamental mismatch between the AI's world and, well, our world. See, an LLM's knowledge is built on this gigantic but totally static pile of data from the past. Its entire worldview just stops on a specific date. Meanwhile, our world, it's happening right now, constantly churning out new information, new events every single second. Right, so this gets us to the heart of the problem. This idea of an AI being frozen in time, it's not a bug or a mistake. It's actually baked into how these things are designed. Let's dig into what that really means for you and me. Okay, so the term you really need to know is knowledge cutoff. Just imagine you spend all of 2023 training a super powerful AI. You feed it everything, books, articles, all the websites, the whole shebang, right? Right up to the very last day of the year. It becomes an absolute expert on 2023 and all of human history before it. But then you ask it who won a championship in 2024, it has no clue. Poof! Its world just ends on December 31st, 2023. And I bet I know what you're thinking right now. Well, why not just keep updating it? Why can't we just hook it up to a live feed of the internet and let it learn as things happen? It's a great question. And it turns out that idea runs headfirst into another huge technical wall. Well, that hurdle has a name. It's called the context window. The best way to think about it is like the AI's short-term memory. It's the absolute maximum amount of information it can juggle in its head at one time. Now, for a model like GPT-4, that window is massive. We're talking about 100,000 words or so. But it's still not infinite. You just can't cram the entire live internet into that short-term memory for every single question you ask. No way. Okay, but this is where it gets really cool. Because instead of trying to solve this impossible problem, building an AI that knows everything all the time, people came up with this incredibly smart, almost sneaky workaround. And it's a technique called RAG. And the idea behind it? It's so simple, it's brilliant. We accept that LLM can't be all-knowing, so what if, instead of trying to teach it everything, you just gave it the perfect little cheat sheet with exactly the right up-to-date info it needs, right when it needs it? This right here, this analogy just nails it. An AI has absolutely no idea about your specific house, right? It's never seen it. But if you hand it your house's floor plan, that external, super relevant document, along with your question, well, now it can easily read the plan and tell you the answer. That floor plan, that's the cheat sheet. And this whole process has an official name, Retrieval-Augmented Generation, or RAG for short. It's really a two-part dance. First, you retrieve the right information, that's our floor plan, from some outside source. Then you use that info to augment the LLM's brain, giving it the context it needs to generate a way better, way more accurate answer. So that's the big picture. But what's happening under the hood? You type in a question, what actually happens next to get you that smart answer? Let's walk through it, step by step. It's this really elegant four-step dance, basically. First, there's your query. That's just you asking a question. Instantly, the system goes and searches an external knowledge base to retrieve the most relevant documents. Think of it like a librarian instantly finding the exact right page in the right book. Then, the system augments your original question by packaging it together with that new info it just found. And finally, that whole bundle gets sent to the LLM to generate an answer. But now it's armed with all the context it was missing before. Now, I know this might sound a little bit technical, a bit abstract, but here's the secret. You've probably used RAG today and didn't even realize it. This tech is quietly becoming the engine behind some of the coolest AI tools we use every single day. You know when Google gives you one of those AI summaries at the top of the search results? That's RAG, pulling fresh info from the top web pages. Those amazing AI coding assistants that seem to understand your entire project? That's RAG. There are even specialized tools for lawyers that use it to sift through millions of legal documents in seconds. It's basically the secret sauce powering so many of these tools. So, why all the hype? Why is RAG so critical for the future of AI?
Well, it's because it solves a bunch of massive problems all at once, which makes AI not just more knowledgeable, but also way more practical and, frankly, more trustworthy.
I mean, the advantages are just massive. With RAG, you get accurate, up to the minute answers. You get to avoid the ridiculously expensive process of constantly retraining your model. It lets an AI become an expert in specialized, even private data, like your company's internal wiki. And this is a big one, it can actually cite its sources so you know where the answer came from, making the whole thing much more transparent. Oh, and we can't forget about the money. We're talking millions, sometimes tens of millions of dollars, to fully retrain one of these big models from scratch. RAG lets you get fresh, current results for a tiny, tiny fraction of that price. It's a total, absolute game changer for making this technology accessible. So, when you boil it all down, here's what RAG really does. It doesn't necessarily make the AI model itself smarter, it makes it wiser. It gives it the right knowledge at just the right time. Think of it this way. It's the difference between having to memorize every book in the library and just knowing how to use the library card. And that kind of leaves us with this big, exciting question. What other impossible AI problems are out there that we could solve, not by trying to build a bigger brain, but just by figuring out the right cheat sheet to give it?